Hi, today we're going to talk about two Objective-C constructs, and these are called categories and extensions. They do similar things, but they're different in ideas. So let's get started. A category is a C type, an Objective-C type. It's kind of like a class, but it contains only methods. A category allows us to add methods to an existing class, even if we don't have the source for that class's implementation. Even if we didn't write the class. For example, we can add methods to NSObject. We don't have the source for NSObject, but we can add methods to it by using a category. We can add categories to any class, even those in the iOS frameworks, as I just said. The methods of a category actually become methods of that class, as if they belonged to that class. In any app that does two things, it must contain the category file, and the class that we're going to use those category methods in must import the category file. So categories are named by default after the class to which they add methods. And this is going to be set up for you when you create a new category in Xcode. It'll be the class name, NSObject, NSString, one of your class names, and so forth, plus, and that is actually the plus symbol, and then the category name, .h and .m. For example, a category declared on NSObject containing count methods might be named NSObject plus counting h and NSObject plus counting m. Now, unlike a protocol, when we use delegation, a category does implement the methods that it declares in its header file. So we need both a header file containing the method declarations and an implementation file containing the actual implementations of those methods. Now again, a category cannot use properties. So no properties in a category, only methods. So what do we use this for? Well, most importantly, to extend functionality for existing classes. For example, we'd add a word count ability to an NSString, and that's what we do in the demo. But we can also use categories as an alternative to subclassing when we only require methods. Some of our foundation objects are relatively difficult to subclass. There are requirements for subclassing those foundation objects. If all we want to do is add new functionality or add new methods to those classes, then it's usually much easier to use a category rather than subclassing the class. For instance, if we want to create a class that is a subclass of NSArray, subclassing NSArray, we have to do a lot of different things. But actually just putting a category on NSArray is very simple because the underlying class still exists. And once again, I want to underline this point. Categories cannot contain properties, only method declarations and their implementations. The next thing I want to talk about are extensions. A class extension really provides a way to add private properties and methods to our own classes. So if you come from an object-oriented language such as Java or C++ or something like that, you know that we can have private properties and private methods, static things, and so forth. And so far in Objective-C, we haven't seen a way to do that. We know we can declare an ivar and make it private, but we can't make a property and declare it to be private, let's say. The private class members that we want to declare are in an interface block, but we put this interface block inside the implementation file, and this is called a class extension. We can also declare an extension in its own file and then import it into the class. But really an extension is an interface file. It's a header file. Or it's just declared inside the implementation in a small interface block at the top of the implementation before the implementation block itself. We can also, and this is very neat, we can also use extensions to grant a read-write status to the class for a read-only property declared in the main interface. Well, why would we want to do that? How does that even make sense? Well, this is like having a public getter and a private setter for a property. Think about it. If we define a property to be read-only, then any other class that uses an object of this class won't be able to write that property. In other words, a setter won't be created. But if we, in the extension, rename that property, or use the same name, but reinstantiate that property, and then grant read-write status to it for the class and that class's direct object, that property will have both a getter and a setter. So within the class implementation itself, both of these statements would work. Self.myint equal 4, that's a setter, and number equals self.myint, that's a getter usage. Those would both work. But outside of the class, only number equals self.myint. In other words, only the getter will work. So this is a very nifty way to make a private declaration that is external to the class. In other words, a getter-only kind of implementation, and then a setter and getter implementation for the class within itself. This all happens in the synthesize statement. So now, what will happen is, when we declare it in the main interface of the class and declare a property to be read-only, then the synthesize statement will synthesize only a getter for that. But if we put in an interface block in an extension that property is read-write, then within the class we will have a setter and a getter. So remember this technique. It's very nice in order to promote better encapsulation within our classes. Thank you very much.